So welcome to my video discussion for class activity number 2. So we must discuss at least one problem. So I'm choosing number 1. So the problem is, in a restaurant called Binary, a comfort room is designed to accommodate 3 people simultaneously. The owner is planning to install a sensor in each cubicle. Outside the comfort room, 2 light bulbs will be set up, indicating the number of occupied cubicles. Each bulb represents a binary digit that lights up based on the number of occupied cubicle. Now design a system that counts the number of occupied cubicles and use the bulbs to display that number in binary form. Note that the light bulbs represent a binary number. So I'm gonna go first to my solution before I go to my design. So as you can see, I'm gonna zoom in. We have 3 cubicles, right? So it's represented by these variables A, B, C, and now 2 outputs to represent the 2 bulbs. So first I went to uh, place its truth table. I want to find out uh, the corresponding uh, variables so that I may come up with my K-map. So since we have 3 inputs, we are expecting to have 8 combinations, right? So to summarize my truth table, so I have here for each, as you can see, for this A0 represents the LSB, right? So it's 2 raised to 0. So it is equals to 1. And A1 is represents 2 raised to 1. So its value is 2. So based on the information from the truth table, for so every only if only one is being represented by logic 1, so it's gonna represent here 1 for this 1, and for this we have 2 logic 1s, right? So it must the A1 must be logic 1, 0 here 1, so 1, 2 logic 1s, 1 0, it represents 2, 1 1 represents 2, it's A1, 1 1 1 represents 3, so 2 plus 1, 1 1 logic 1 for A1, logic 1 for A0. So to further uh, to implement the design, we must have the K-map. So for A0, we have here the min terms for term number M1, M2, M4, and M7. And for A1, we have M3, M5, M6, M7. So further proceeding to the K-mapping, we have here for the A0 as from the truth table, min terms of 1, 2, 4, 7. So here 1, 2, 4, and 7. So by grouping them, unfortunately, we only have one grouping for each. We cannot further group this only once. So we have here first, it's A complement, B complement, C, A complement, B, C complement, A, B, C, and A, B complement, C complement. So the final equation for A0 is A complement B complement C plus A complement B complement B C complement A B C plus A B complement C complement. So for A1, the K mapping, so the min terms are for 3, 5, 6, and 7. 3, so 3, here is 5, 6, 7, right? So grouping them, one a pair here, a pair in the middle, and a pair at the bottom. So for the first pair, it's BC. Second pair is AB and AC. Therefore, A1 is BC plus AB plus AC. Now we have the equations, right? For our 2 outputs. Let's proceed to the solution for the design. We have here problem 1, right? Now, based on the K mapping, so as you can see, we have here from derived from the K mapping here for A0 and for A1 here, BC, AB, AC, then OR gate. So now let's test the solution. So for example, a person occupies only one cubicle. It would be represented with 0, 1, which corresponds to 1. So whatever cubicle, whatever it may be, it will just be 0, 1 because 0, 1 is equals to, from binary, equals equivalent to its decimal is 1. 1 cubicle, 0, its binary form is 0, 1. How about 2 cubicles? It's 1, 0. A1 will light up. Whatever the position of the cubicles, as long as it's 2, as you can see. It's for the 2, for the 2, decimal number 2, its equivalent is 1, 0. 1, 0 binary. How about 3? 3 cubicles occupied, as you can see, 1, 1, which is corresponding to 3. So based on the K-map, this is my final design. So this is my solution for problem number 1. Thank you for watching.